Okay, so today we're going to talk about three statements that you can use to kind of be more specific with how you want your loops to work. We're going to talk about the break statement, we're going to talk about the continue statement, and we're going to talk about the exit method in order to leave your program. Now, starting with the break statement, I'm going to run the program and then we're going to talk about how the break statement works. This is definitely going to be the statement that you use the most. You will use it often in your program, so please make sure that you practice with it. But essentially, over here, we have a program that counts up by multiples of 6. So it starts up by 6 and it asks you for the next number. Oh, I'm not very good at this game. Count up by multiples of 6, starting at 6, 12, 18, etc., etc. Now, if you ever make a mistake, then what's going to happen is it's going to say that's not the right answer. It's time to close the program. So it could run indefinitely as long as you keep successfully counting up by multiples of 6. Now, how exactly are we going to make this work? Now, there's quite a few ways, one of which is by using a break statement. And you will start to find, especially now that we're entering loops and you have to start thinking critically a lot more for when you're programming, there are many different ways to write a program, all that accomplishes the exact same thing. That's why one of the biggest concepts and one of the biggest debates in coding is how to make your code the most efficient in order for your code to either A, have the least lines of code, B, run the quickest, or C, look the most organized, right? These are all things that people argue about all the time. Now, in this code, what I do is I have a while statement. So I'm using a while loop. And notice that in the condition, in the parentheses, instead of having a condition which returns a Boolean statement true or false, I just have the direct Boolean statement true. That means that this loop is always going to have a condition that's true. That means that this loop is always going to run. It will keep running forever and ever and ever. All right, which is normally going to be a problem because you want your program to end eventually, but the break statement kind of allows us to fix this problem. So I have a while loop that's going to run indefinitely. In this while loop, I take my answer, which starts at 0, and I increment it by 6. And then I ask the user what's the next number because I'm going to make sure that whatever the user inputted is equal to the answer that I'm looking for. So I take the user input and then I have an if statement that says if the user guess is not equal to the answer that I expect, then I am going to break. All right, and keyword break means that I am going to leave the current chunk of code that I am in. It means that in this scenario, I am going to leave this loop. It's like an emergency exit. Hey, whoa, something's wrong. Let's get out of here and continue with my code. So now there is more than one way to exit a loop, not just through the condition stated next to the while, but also through a break statement, which can be useful in many different scenarios when you want to emergency eject from your loop. Now, I don't know if I've mentioned this in the if statement loop, but notice that my if statement doesn't include any brackets, right? Normally, it would look something like this. Now, you'll see that I do this very often. When you have an if statement, or even when you have a loop that only has a single line of code, you don't have to include those curly brackets. Which goes on to say that if you don't have those curly brackets, you cannot have more than one line of code within your if statement or your while loop. So it saves you a little bit of room, makes your code a little bit simpler and easy to look at, but make sure that you're only using that shortcut in the appropriate scenarios when you only have one line of code within an if statement. Okay, so anything that I would have written after this would not be in the if statement. Now, after I break, after the user guesses incorrectly, I am just going to print out this is not the right answer because I would not have entered this if statement if it was the right answer. This is not the right answer. I'm going to close the program now. Okay, so the break is extremely useful. Make sure that you're practicing with it because you will come to depend on it in many different scenarios. Now, the continue statement is one that we use, but not as often as the break. So this program is, let's run it and see what it does before we talk about it. So reading the instructions, it looks like I'm going to count to 100, skipping any multiples of 5, and we do just that. So 1, 2, 3, 4, 6, 7, 8, 9, 11, blah, 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 all the way to 99. Now, how do we accomplish this? How do we skip all multiples of 5? Well, we're going to be using the modulus, right, which takes our remainder. But let's take a look. I have a counter, which is going to count from 0 to 100. And what I do is I have a while loop that is going to keep running as long as the counter is less than 100. Right? These programs you could do with a do while loop as well. Most programs that you could run with a while loop, you can also use a do while loop. It just depends on which one you're more comfortable with and which one better suits the situation. Remember, a do while will always run at least once. Now, I start by increasing count. So I suppose it starts at 1. Okay, I increase it to 1 right away. And then I check if this is a multiple of 5, right? If count modulus 5 is equal to 0, so in other words, if I take my count, if I take the number that I'm trying to print out, and I am dividing it by 5, and it has a remainder of 0, then that means that it's a multiple of 5. 5, 10, 15, 20, 25, 30, those all have a remainder of 0 when you divide them by 5. Again, I don't need those curly brackets because I only have one line of code within my if statement, and that line of code is continue. So where the break statement automatically leaves the current loop that you are in, the continue statement instead automatically jumps to the top of your loop. So it essentially skips any code that would be underneath it and just goes directly to the top of the loop and checks again, hey, is my count less than 100? It continues to the next iteration of the loop, which means that if I enter this if statement, which means that if my count is ever a multiple of 5, then I will not be running this line of code that prints it out. I will simply be jumping up and increasing count to 6, to 11, to 16, right? So this allows me to skip the line of code that would normally print out those multiples of 5. However, if count is not a multiple of 5, then I will not be entering that if statement, and I will therefore be moving forward with my code as I normally would, and I will print out the count as it is. Okay, and that effectively allows me to skip all multiples of 5. So continue is extremely useful when you want to jump to the next iteration and not run the rest of the loop for the current iteration. Okay, so you will find uses for it, but you won't use it nearly as much as you will use the break statement. Okay, we've actually already used the break statement before. We used it in the switch control structure, because the moment that we entered one case of our switch, we left with a break statement because we're done with it. Now, the last thing that I want to teach you is one that, if you're coding right, you will hopefully never use in your code, but it is nice in certain scenarios, but you really want to try avoiding using it whenever you can. This is this line of code right here, system.exit, and in brackets, the number 0. This will just end your program right away. Okay, which can be useful sometimes when the user inputs something that's wrong and you want to just shut down your program. But a proper and well-formed program will only have one exit point, and that is when you reach the end of your code. So keep this in your back pocket in case you ever need it, but if you're doing things correctly, you will never need it. Keep that in mind. Now, let's actually take a look at what this code does. So we can see this program will add 5 positive numbers together. What is value 1? Okay, so we're going to add 3, we're going to add 4, we're going to add 8, we're going to add 9, we're going to add 1. The sum of your numbers is 25, exactly as planned. Now, if I accidentally input a negative number, it's going to say you cannot input a negative number, and it is not going to ask me for the 4th value. It is just going to shut down the program. Okay? Now, what does it look like in my code? Well, in my code, I have my counter, which is going to ensure that my loop runs 5 times for the 5 numbers. All right, over here, I started the counter at 1, and you'll notice down below that it repeats as long as count is less than or equal to 5. Okay, now normally I would start count at 0, and I would run it while count is less than 4. That would make the while loop repeat 5 times as well, but I'm actually using count within my loop as an output, so you'll see how it becomes much more user-friendly if I run from 1 to 5 instead of from 0 to 4 with my count. I have an integer called sum, which is naturally going to keep track of the sum of my variables or my inputs, and I have temp, which I assume is going to be a temporary variable used down below. Now, my while loop is going to run 5 times while count is less than or equal to 5, and I print out what is value number count. And this is why I started count at 1, because the very first thing that I wanted to print out is what is value number 1, not what is value number 0. This makes it more user friendly. So what is value number 1? I'm going to take the user input. I am going to place it in temp. Okay? Now, what I do is I check, hey, I told them to put in only positive numbers. So is temp not a positive number? If temp is negative, if it's less than 0, then I'll give them the user-friendly error message, you cannot input a negative number, and I'm going to shut down my program right there, system.exit. As long as temp is positive, then I can continue with my program, right? I can add my temporary value to my sum, and I can increase my count to 2. Ask them for the second number. Rinse and repeat 5 times until they ideally input 5 positive numbers. I add them all to my sum, and then once count becomes 6, I can leave this while loop. And I can print out the sum of your numbers is whatever sum is, and I'm good to go. Okay. A much more user-friendly way to do this would be to simply put in the word continue. So instead of shutting down the program when they input a negative number, I am simply going to bring them back to the top. And remember, at this point, I still haven't increased count. So we might say that I'm in the same iteration. I bring them back to the top and I say, okay, you inputted a negative number. Let's try this again. What is value number count? And count will still be the same because I haven't increased it yet. I only increase it when I successfully input a positive number. So if I run my program like this, and if I planned it out correctly in my head, what's going to happen is, let me just shut down this current run. Okay, what is value number 1? 6. What is value number 2? Let's say it's -9. You cannot input a negative number. Let's try again. What is value number 2? This is what we call error handling. Okay, I have a whole lesson on error handling coming up later, but error handling is you making a user-friendly program so that when the user messes up or tries to break your program, which they will, they're really bad at running your program, you tell them you did something wrong and you ask them again, try again. All right, that way you don't come up with an error message, and that way they can keep running the program despite their mistake. So, okay, I'm so sorry for inputting a negative number. Let's get some positive numbers in there. Not very original, so I'm going to make them all the number 6. The sum of your numbers is 30. So this would be a much more user-friendly program because you're not having more than one exit point. And also, when the user messes up, you're giving them another chance. Okay, so keep that in mind. Keep system.exit in your back pocket, but try not to use it. The break and the continue statement, you definitely need to know for many different scenarios, though. So make sure you're doing your homework and shoot me an email if you guys have any questions that I can help with.